Hello children, our next chapter is 7 Permutation and Combination. We always use some pin number, whether it's a 4-digit number or a 6-digit number, to lock mobile phones, or we can use an ATM or any other things. Say for example, if you use a 4-digit pin to lock the mobile phones, which has been taken from the 10 digits from 0 to 9. This lock can be opened if 4 specific digits are arranged in a particular sequence with no repetition. Otherwise with repetition also. But if you remember just only one digit, which is the first digit, say 7, in order to open the lock, we have to think about the other 3 digits. We start listing all possible arrangements of 9 remaining digits taken 3 at a time. But it's clear that while using mobile phones or ATM, we will have only 3 attempts to make it. That's different. But here, remembering only one digit and the remaining 3 digits, we can make the possible number of sequences which are very large. Here in this chapter, we shall learn some basic techniques which will enable us to answer this question, listing 3-digit arrangements. These techniques will be useful in determining the number of different ways of arranging and selecting objects without actually listing them. So as a first step, we are using a principle which is most fundamental to the learning of these techniques, which is fundamental principle of counting. So let's consider a following problem. Mohan has 3 pants and 2 shirts. So how many different pairs of pant and shirt can be dressed up with? There are 3 ways in which a pant can be chosen, because there are 3 pants, and there are 2 ways in which a shirt can be chosen. For every choice of a pant, there are 2 choices of shirt. Then there are 6 pairs of a pant and a shirt. So for first pant, we can choose 2 shirts. And for second pant, we can choose 2 shirts. And for third pant, we can choose 2 shirts. So it will be 3 into 2, which is 6. Therefore, there are 6 pairs of pant and a shirt. Similarly, if Shabnam has 2 school bags and 3 tiffin boxes and 2 water bottles, in how many ways can she carry these items? So there are 12 possibilities. 2 school bags, 3 tiffin boxes and 2 water bottles. So there are 12 possibilities in which she can carry these items. A school bag can be chosen in 2 different ways, tiffin box in 3 different ways, and water bottles in 2 different ways. So 2 into 3 into 2, which is 12. There are 12 possibilities in which she can carry these items. The problem of solving these types of questions by applying the following principle, which is known as the fundamental principle of counting, or simply the multiplication principle. It states that if an event can occur in m different ways, following which another event can occur in n different ways, then the total number of occurrence of the event in the given order is m into n. The above principle can be generalized for any finite number of events. The events in those questions could occur in various possible orders, but we have to choose any one of the possible orders and count the numbers of different ways of the occurrence of the event in this chosen order. So fundamental principle of counting, the total number of occurrence is given in the order is m into n ways. Exercise 7.1, first question. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that repetition of the digit is allowed. Here a 3-digit number can be formed, but repetition is also allowed. For example, 335 or 553. Repetition is allowed. We have to form 3-digit number. There will be as many ways as there are ways of filling 3 vacant places. So it's given 5 digits, 1, 2, 3, 4 and 5. Repetition of digits is allowed. The units place can be filled in any of the given 5 digits. So units place can be filled in any of the 5 digits, 1, 2, 3, 4, 5. So there are 5 numbers, so it can be filled in 5 different ways. Tens place can also be filled using these 5 digits. There are 5 different ways of filling the tens place. Here the repetition of the digit is allowed. So here also it's 5 different ways. And the hundreds place also can be filled in 5 different ways, as the repetition of the digit is allowed. It can be filled either by 1, 2, 3, 4, 5. So by fundamental principle of counting, the number of ways in which 3-digit numbers can be formed from the given digit is 5 into 5 into 5, which is equal to 125. Second subdivision, repetition is not allowed. We have to use these 5-digit number and have to form 3-digit number. The units place can be filled in 5 different ways. So any number, it can be filled by any 5-digit number by 5 different ways. And the tens place, here the repetition is not allowed. If this place is filled by 1, here it will not repeat 1 here again. So this place can be filled in 4 different ways. Once the unit space is filled in 5 different ways, then the tens place can be filled in 4 ways. Here the repetition is not allowed. And the hundreds place can be filled in 3 ways. So the number of ways of filling the units place is 5. The tens place can be filled with any of the remaining 4 digits. If it is 1, then we have to fill these places with any of the remaining 4-digit numbers. And the hundreds place can be filled with, again if it is filled with any number 2 or something, then it can be filled with the other remaining digits, either 3, 4 or 5. Thus by the fundamental principle of counting, the number of ways in which 3-digit number can be formed without repeating the digits. Here repetition is not allowed. So 5 into 4 into 3, which is equal to 60. Second question, how many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6 if the digits can be repeated? So digits can be repeated means repetition is allowed. The number can be repeated. If this can be filled with 1, so here you can fill it with 1 also. So repetition is allowed. So you have to frame 3-digit even numbers. So the units place should be an even number. It can be filled by 2, 4 or 6. So even numbers 2, 4 or 6. So the unit place can be filled by the even number 2, 4 or 6. So that we can form a 3-digit even number. So there are 3 even numbers. So units place can be filled in 3 ways. And the tens place can be filled in the other 6 digits. 1, 2, 3, 4, 5, 6. There are 6 digits. So tens place can be filled by 6 ways. And the hundreds place can be filled by 6 ways. Here repetition is allowed. The number can be repeated again and again. So by fundamental principle of counting, 3 into 6 into 6 which is 108. There are 108 possibilities of forming the 3-digit even numbers. Third question. How many 4-letter code can be formed using the first letters of the English alphabet if no letter can be repeated? So we have to form 4-letter code using the first letters, 10 letters of the English. No letter can be repeated. So that means a repetition is not allowed. If E is filled in the last place, so E should not be repeated either of the 3 places. So repetition not allowed. The first place can be filled in 10 different ways by using first 10 letters of the English alphabet. So the first place can be filled in 10 different ways, following which the second place can be filled in by any of the remaining 9 letters. Once the letter is filled, then it could not be repeated. So the second letter can be filled in 9 different ways, and third letter can be filled in 8 different ways. Once it's selected or filled in the second place, it should not be repeated on the third or first or fourth place. So the fourth place can be filled in by any of the remaining 7 letters in 7 different ways. Therefore, by fundamental principle of counting, the number of ways in which 4 vacant places can be filled in 10 into 9 into 8 into 7, which is equal to 5040. Hence 5040 4-letter codes can be formed using the first 10 letters of the English alphabet if no letter is repeated. Fourth question. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once? So we have to construct 5-digit telephone numbers. It starts with 67. We can construct using the digits 0 to 9. If each number starts with 67, no digit appears more than once. That is, repetition is not allowed. Once 6 and 7 is used, it should not be repeated. So the units place can be filled with other 8 digits other than 6 and 7. So without using 6 and 7, we have to fill this units place with 8 different ways. Except the digit 6 and 7, the remaining digits are 0, 1, 2, 3, 4, 5, 8, 9. So there are 8 digits. The units place can be filled in 8 different ways, following which the tens place can be filled. Again, if one digit is filled in this place, the remaining digits are 7. So the tens place can be filled in the remaining 7 digits in 7 different ways, and the hundreds place can be filled in any of the remaining 6 digits in 6 different ways. Therefore, using the fundamental principle of counting, the required number of ways in which 5-digit telephone numbers can be constructed is 8 into 7 into 6, which is equal to 336 by fundamental principle of counting. Fifth question. A coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? When a coin is tossed once, the number of outcomes is 2. That is head and tail. So number of outcomes is 2. In each throw, the number of ways of showing a different face is 2. So the coin tossed 3 times. So the required number of possible outcomes is 2 into 2 into 2 by using fundamental principle of counting, which is equal to 8. Sixth question. Given 5 flags of different colors, how many different signals can be generated if each signal requires the use of 2 flags, one below the other? Each signal requires the use of 2 flags. There will be as many flags as there are ways of filling 2 vacant places. So the upper vacant place can be filled in 5 different colors. That is in 5 different ways. Any one of the 5 flags. Then the lower vacant place can be filled in 4 different ways by any one of the remaining 4 different flags. So different colors in upper place and lower place. Therefore, by FPC, fundamental principle of counting, 5 into 4, which is equal to 20. So we can generate 20 different flags. So this exercise is based only on fundamental principle of counting, which is the total number of occurrence of the events, which is given in the order m into n ways. This principle can be generalized for any finite number of events, for 3 events, 2 events, etc. If an event can occur in m different ways, following which another event occur in n different ways, then the total number of occurrence of the event is m into n ways. This is known as the fundamental principle of counting. Thank you, children.